first session to join me. Today your name fate, that's to be perfect. So we will have in this first part of the session 2 presentations and presentation via video. Then we have a break, a coffee break at 4:30. So we can all take a deep breath and say, wow, this is a very interesting workshop that we are actually having. And then we continue with the rest of the session and the beginning of the second session. So this first session is actually looking at how shipbuilding and selected marine infrastructure, such as aquaculture, oil and gas platforms, will increasingly be impacted by advances in digitalization, new eco-friendly materials and processes. So we were really looking at how innovation, which is really impacting many of these sectors, should be leading to the greening of these sectors. So to start with, I welcome my colleague Laurent Daniel from the OECD, who's going to tell us about the efforts of his group in terms of looking at green ships, greening the shipbuilding sector. So, Laurent?
Thank you. Hello. So, should I use? Yes, I can use that. Or this one, perhaps that. Okay, it's okay. It's okay. Okay. Thank you. Thank you very much for this invitation. I'm very happy to be here in Naples for my first time here. So, as said by. You can also use this one if you prefer. This one works. Okay. Perfect. Okay. Thank you. So I will present you some elements regarding the assessment of selected policies promoting the construction and operation of greener ships. So these results are based on a report that will be available soon in the context of a workshop on 20 November, which is one of the 3 events of the OECD Ocean Economy Week, which was mentioned by Claire. So, and with another event just after the Green Growth and Sustainable Development Forum on greening the ocean, and the third event, the symposium on measuring the ocean economy, organized by Claire and her team. So, I mentioned here that I put on the table at the entrance some copies of the agenda, so please feel free to take some, and you have the information to register if you're interested to participate in this event on 20 November. So, today I will present some of the policies promoting greener ships and their results, their effects on various elements. So, first, policies addressing climate change, so aiming to reduce greenhouse gases emissions. Then policies promoting the reduction of air pollutant emissions, the effect of the new Ballast Water Management Convention established by the IMO, and the effect of these policies on innovation. So here on this slide, on this table, you can see several examples of policies aiming to promote the production, the construction and operation of greener ships. So what is striking is these policies at our very various levels. They are at international level, so mainly taken by the IMO in the context of the discussion at the IMO. At the regional level, so at the regional level, we talk about emission control areas, which are sub-parts of the ocean, which voluntarily have chosen to have stricter rules, and notably on 2 aspects, NOx and SOx emissions, and also national policies. So you see various countries, and this list is not comprehensive. I think that Italy, France, many other countries took also some actions, but we use the information that we collected through a questionnaire which was sent to the W6 member. What is the W6? The OECD Council Working Party on Shipbuilding is the OECD committee that I'm working for. And in the context of this questionnaire, we collected some information about these policies. So first, policies addressing climate change. Our colleagues from the International Energy Agency so have calculated that the international maritime shipping industry currently accounts for about 800 million tons of CO2 equivalent emission per year, which is quite big. And without strong action, this figure is expected to double by 2060. However, there were some, as you know, some measures taken at the international level to address climate change. There was recently the Paris Agreement, but international shipping is not included in this agreement. The Kyoto Protocol, and what is interesting is the Kyoto Protocol requests that the IMO works on the limitation or reduction of GHG emissions from ships. And of course, so the IMO, International Maritime Organization, has implemented the Energy Efficiency Design Index, so EEDI, which is a mandatory measure. So all new ships should respect a certain level of efficiency in terms of CO2 emissions, depending on their ship types and depending on the year. So there is a gradual tightening of the requirements for ships. So it's shown on this slide. You can see that minimum energy efficiency level are gradually tightened from today, so phase 1, to 2025 and after for phase 3. And but what is interesting is that the EEDI is a 0-1 system. So you should respect it, but you're not incentivized to go further. So if you respect it, it's fine. And but your over compliance is not like I can say you don't get additional benefit if you are over compliant. So this slide shows that the EEDI is expected to have a significant effect in terms of CO2 emission reduction. So the dotted line shows the business as usual scenario. So without EEDI, what would be the CO2 emissions for selected ship types? So the bigger ship types, which are bulkers, tankers, and containers, and the black line shows the 3 segments in total. So you see that EEDI has a significant expected effect from now to 2035. It's a complicated slide, but what it shows is that there is an improvement. We show on the bottom charts the distribution of EEDI level. So basically the energy efficiency performance of ships from 2013, so before 2013, then 2013, 2024, and after 2015. So there is a slight shift on the left, which is good, so an improvement of the EEDI level. But the upper slide shows that ships really respect EEDI levels, but with really not over-compliance. So it's, as I said, it's a 0-1 system. And some experts would like that we promote over-compliant ships more than currently. So it's quite a complicated chart, so I won't describe it in details, but it shows that you can improve the energy efficiency of a ship with various parameters. So you can reduce the speed. The reduction of the speed is a big factor to reduce CO2 emissions by your ship. On the right and the top, you can see SFC, which is SFC is a measure of the surface resistance of a ship. So how you lose energy because your hydrodynamism is not perfect. So you can improve that. Admiralty, it's a very complicated parameter which shows also how you have optimal power of your engine given the speed. And lightweight, it's LW on the right and the bottom is also a parameter. Basically, I will come back to that. This slide shows that EDI led shipbuilders to improve the design of the ships, but not to a large extent to reduce the design speed of the ship. So it's what I just said. So a summary of an assessment of the EDI. So it is expected to have a significant impact on shipping. It would contribute to reduction by something like 30% of the emissions from bulkers, tankers, and containers between 2015 and 2035 as compared to a business as usual scenario. It leads to an improvement of the vessel design rather than a reduction of the design speed. And, as I said also, it's more effective to restrict low energy efficient vessels, so the vessels which are not respecting the EDI requirement, rather than promoting over-compliant vessels. So it could be necessary to implement new measures to be over-compliant. So our colleagues from the IEA, helped by the International Transport Forum, send a submission to the IMO. They have a special subgroup dealing with GHG emission, and they proposed additional measures, so to reinforce EDI, so to be stricter in terms of EDI requirements. For instance, large containers, you've heard about these 20,000 TEU containers, huge ones. They already respect the 2035 EDI levels. So perhaps they can do more if, according to some experts, I think our colleagues from IEA, ITF, they believe that. Additional efforts in terms of retrofitting, using more low-carbon fuels, wind assistant, which is a very promising technology, etc. So additional efforts could be necessary. Secondly, air pollutants. So as you have perhaps heard, in some ports suffer from ships who come to their ports because of SOx emission, NOx emission. So I will go fast because I have not so much time, but what can I say is that on this slide that we see that the performance in terms of SOx and NOx emissions are really better in these emission control areas. So this sub-part of the ocean, like the Baltic Sea, North Sea, around North America and the Caribbean Sea, which implement this SOx and NOx additional regulation. So it's quite efficient. And I will skip all this slide, it's very detailed, but just going to the conclusion is that, so you see, I perhaps, Claire, if it's fine with you, we can circulate the slide. And I will just mention that because thanks to these emission control areas, we observe that owners of ships based in these emission control areas or flagged in these emission control areas construct more ships with innovative, energy-efficient technologies. So LNG fueled vessels, marine gas oil vessels. So it has also an impact on construction of more efficient vessels. So I think it's quite interesting to see the effect of these emission control areas. Ballast water management. 2 weeks ago, the new regulation by the IMO entered into force regarding ballast water management. What is ballast water? Is the water so discharged by ships in some waters, and sometimes this water includes some species that destroy ecosystem in other areas. So they are very harmful, and as a consequence, the IMO implemented a new regulation, the Ballast Water Management Convention. So all new ships, they should have this ballast water management system that avoid this problem of this transportation, accidental transportation of invasive species. And existing ships, they should gradually be retrofitted to have this ballast water management system. What is interesting is that it's a huge, it will require a huge effort in terms of retrofitting. And I will shift also to the conclusion already that it would represent only the effect of ballast water management convention. It will occupy 20 to 50% of retrofitting capacity in the world. So all repair yards should be happy because they will have a lot of activities because of that. But it's quite perhaps costly for ship owners, and also it's a challenge in terms of managing to implement that in a short period. Innovation, also I have many slides, you can look in details. I will just mention that it's an obvious result, but the policies led to a big jump in patent activity. So we see that when we implement policies aiming to produce and have more operations of greener ships, we see a higher activity in terms of green patent. And I think it's interesting also to stop on this slide for 1 minute. This slide shows the technologies that would allow to have greener ships and their cost. So on the left, on the horizontal axis, you can see from the less costly, and it's not even costly, you save money if you implement propeller polishing, if you implement autopilot, so you save money already, and you reduce your CO2 emissions. And from the more costly, and also with their effect in terms of CO2 emissions. So there is a huge potential to improve the environmental performance of ships. So I will skip all this slide, I have so much, but I think the best is you can look at my slide, and I'm happy to answer your question now or by email when you want. Final word, so you can see international regulation has big impact on the environmental performance of ships in terms of also patent activities, and it also gives a huge business opportunities for shipbuilding and repair industries. And it's the same, you can say it's basically the same for also regional and national measures. Thank you, I stop here because I think of time constraints. Thank you. Thank you.
Thank you very much for your very rich presentation, and of course it will be available to you because I think, particularly in your committee, you're doing some very groundbreaking work in terms of looking at the policies and regulations that are contributing to drive some of the innovation that we're seeing. So I think it's a very important aspect of the innovation that we need to keep in mind. Now we're Now we are going to the second presentation in this particular session, where we are lucky to have Mr. Dohrn, who's the head of innovation from Integrale. So we're very happy to have the private sector represented, so you can share with us your thoughts on what type of innovation is contributing to sustainable shipbuilding. So thank you very much for being here.
Merci, Madame Julie. Thank you for invitation to the OCD and to the Stazione Zoologica di Napoli. My name is Massimo De Benedetti, and I'm responsible for research and innovation in Cantiere. I will how does it work? Okay. I will tell you a little bit about Fincantieri and about how we handle innovation at our premises. And then I will share with you some thoughts about sustainable shipbuilding. Okay. So, what is Fincantieri today? Well, we have been building a ship since 230 years. If you go a little bit southward along the coast here in Naples, you will find the Castellammare di Stabia. That is the oldest shipyard still in operation in the world, and we have the honor to operate this shipyard. So Fincantieri has a long history in shipbuilding. Today is a 4.5 billion company. We have shipyards all around the world. It means that we can build ship in every continent except Africa. We have the most of our revenues outside Italy, because most of our customers are global, and we are something around 20,000 employees, but with all our subcontractors, we mobilitate more than 80,000 people around the world. And what are our activities? Well, we build cruise ship, we build naval ship, we build mega yacht, we build ships for supporting oil and gas exploration, and we build ferries, and also we build marine equipment for our ships. And what is the difference between Fincantieri and all the others shipyards? Well, we are the only one in the world able to operate in the so-called high-tech segments. We are the only one able in the world to build all these high-technology ships. And that's the reason why, and I'll tell you a little bit more in detail after, that's the reason why European industry is surviving against our main competitors from the Far East. The reason is that European industry and Fincantieri in particular has been able to focus manufacturing operation on high added value shipbuilding and not on bulkers, tankers and that kind of ships. I totally agree with Laurent, right? I totally agree with Laurent. Regulation is the most important driver of innovation in this business, because in order to tackle with all the evolving norms and standards, we are forced to innovate. And actually, innovation is the most important force that shapes our competitive environment. Then we have market trends, obviously. We have to cope with how the market is evolving. One of the trends that typically is rising in cruise business, for example, is the concept of smart ship. You know that we are having experience with the smart offices, smart building, and why ships should be stupid. So smart ships is one of the most important trends that we are seeing on the horizon. Then the other important force that we are considering is technologies, and in particular connectivity. Why connectivity? Well, for example, when you are walking around the city, you are used to look at Google Maps and check where you are, looking for a restaurant, looking for a shop, or for anything else. When you are on a cruise ship, it's not so easy, because a cruise ship is a Faraday cage. So any kind of electromagnetic wave has difficulty to propagate. So GPS and all the technologies able to locate you on Earth while you are walking in the city doesn't work on a ship. And that's the reason why it is one of the most important technology trends that we are following. And then we have some other mega trends that are shaping our competitive environment. From these four forces shaping our competitive environments, we defined our most important technological challenges. First, energy efficiency. Laurent before told us about EEDI. EEDI is a sort of regulation that comes from the automotive business, where the corporate average fuel economy forced all the automotive manufacturers to decrease at a very high pace CO2 emission. Like in that business, also in this business, energy efficiency is one of the most important drivers, both for regulation, but also because we have to remember that the fuel price is the most important cost category for any shipping activities, for passenger shipping, for goods shipping, for any shipping activities. Fuel is the most important cost category. That's the reason why energy efficiency is one of our most important drivers. Then we have cost reduction, obviously we have payload. More people I can accommodate on a cruise ship, more happy will be the ship owner, because he will make more money operating the ship. So payload is the third important driver for us, but not only for us, but also for shipyards building other kind of ships. Then we have safety, that is not the first, but is the first, obviously. Then we have weight reduction and perceived quality. We handle innovation and we manage innovation along three pillars. The first one is the technologies that we need in order to comply with the technical specs of a given ship contract. Then we have defined what we call off-the-shelf innovation. There are all those pieces of technologies that we need to anticipate ship owner needs and also final customer needs. And then we have what we call long-term innovation. That is something that we work about in order to rape possible business opportunities that we are not reaping today. We leverage a lot on external sources of innovation. Just one figure, 80% of the value of any ship is made by suppliers. So I can't manage innovation without involving suppliers in my innovation process. And I can't handle innovation without involving academia and research center with an open innovation approach, because as I will share with you later, a ship is a very complex product where it's quite impossible to manage every discipline, every competence, every technology. So we rely on a quite wide innovation network. It is based in Italy and in Europe. Thanks to all these efforts, we won in 2014 a couple of innovation prizes given by the Italian presidency. Then some thoughts about sustainable shipbuilding. What is, in our view, sustainable shipbuilding? Well, I would say that sustainable shipbuilding is building ship, listening and involving each and every stakeholder. That is, in our view, sustainable shipbuilding. So what we are trying to do, what we're doing hopefully, is to involve and listen at all the different stakeholders that are clients, employees, public administrations, local communities, suppliers, partners, the environment, the financial communities. And in dealing with all these different stakeholders, we try to bring our value. Our values are people belonging to our firm, people belonging to the local communities, and people in general belonging to our environment. Then responsibility towards all these stakeholders, but mainly towards environment, innovation, diversification, and obviously the C. It is the element where we make our business. And what is our behavior? First of all, we want to engage all these stakeholders. We want to relate with them in order to discuss all the issues that we can have together in building a ship. So we want to build up a dialogue. We want to bring on our ethics. We want to share values, and we want to bring on continuous improvement. Now some data about what I called before high-tech shipbuilding or high added value shipbuilding. and the role of Europe in this business. In this chart, you can see the evolution of the share of European firm in what we call high-tech shipbuilding. We start from 2004, where only 35% in terms of gross ton of high-tech ships were built in Europe, up to 2015, where about 80% of high-tech ships were built in Europe. And that is very, very, very important, because this is the reason why we are surviving against our competitor from the Far East. This is the key of the European industry. Without this data, we couldn't understand what is our main competitive advantage. And last year, in 2016, the market share of Europe was about a quarter of all the ships made in the world. It was the first time since a long time that European industry that European industry built more ships than the Japanese one and the Korean one. Why? Because in the last year, the so-called standard ships experienced a deep crisis, and that's the reason why European industry emerged. And then the reason why, again, we are surviving quite well. So, what is the quick takeaway of this chart is that shipbuilding is a capital-intensive sector for sure, but in Europe is a knowledge-intensive sector, where we have focused on high-tech vessel, we leverage R&D to keep competitiveness, and we are a part of a larger network of maritime knowledge and expertise. That's the reason why, again, we are surviving. Without innovation, without R&D, without investment in innovation and R&D, European industry would have been killed by our competitor from the Far East. Usually, when we think about a complex product, we think about an aircraft. Usually, we think about A-38 or a fighter or anything going through the sky. But this chart shows that shipbuilding is much, much more complex. Some number. To build an A380, you need 80,000 hours. You need 100,000 parts, and it weighs 537 tons, with just 1 million of code lines to manage all the system on board. If we talk about the least complex vessel, that is a complex research vessel, we are talking about 1 million hours of manufacturing. We are talking about more than 500,000 parts. We are talking about 3,000 tons of weight, and we are talking about 1,500,000 code lines. And this is the least complex among the complex vessels. If we talk about an aircraft carrier, you can see the number. So what is the takeaway of this slide? Shipbuilding is one of the most complex business in the world. Much, much more complex than making an aircraft. And the evolution is quite significant. This is the comparison between a ship built in 1990 and the ship that will be delivered the next year by our cousin in France, STX France. And this is the comparison by the numbers. In the 90s, that ship was about 70,000 gross ton. Now, that ship is 230 gross ton. For a capacity of about 2,000 people 30 years ago, and for a capacity of roughly 7,000 people today. So, the point is that we have to apply a 3.3 factors for size and a 3.5 factor for people. It does mean that ships are larger, but ships are more efficient because the capacity grows more than the size. And the funny thing is that in the last 30 years, each and every year, ships became 4.3% bigger. If you compare with a car, or if you compare with a car, it's quite simple. Four places and 4 places, and that's all. That may be 7. If you compare with an aircraft, and if you compare between the Boeing 737 and the Boeing 747 and the Airbus 380, you will have something around less than 1% of compound average growth rate in terms of capacity. And that's true not only for the cruise segment, but also, and maybe more, for the standard business, where the capacity is steepest than the cruise business. If we talk about technology, we have to consider that the ship is a fantastic integration of very different technologies. If you think about a cruise ship, you have to consider that on a cruise ship lives around from 4,000 to 6,000 people. That is a small village. And it's a small village that is totally independent. Independent for energy, independent for waste management, independent for leisure. It's a small village going around the sea in total safety. And that's the reason why we need to integrate a lot of different and diverse technology. We integrate information technology, we integrate classical discipline like hydrostatic and hydrodynamics and stability. We integrate machinery, we integrate pollutant reduction. So this is just to give you an idea of the complexity that we every day tackle at work. One of the speakers before talked about innovation like evolution, and yes, thank you. And I like very much this analogy because what the product that survives is not the best one. Is the one that fits better with external conditions, and is the one that fits better between the push from technology and the pull from market and from regulation. And this is just to give you an example again of the trade-offs that we have to tackle every day. Energy is needed to comply with a zero-emission ship. Safety with a zero-accident ship. Digitization with an autonomous ship, and assembling with a profitable ship. Well, the colleague before talked about regulation, and I will not talk about it because he gave us a good idea of the evolution that we are seeing today. And what is the point? Is that if we want to pursue a low environmental impact, a low environmental footprint on a ship, we need a structured approach. We need to take into account energy balance, ship's optimization, emission reductions, fuel shifts, in order to lead the change to a sustainable ship. But the point is that, again, is complexity. Is the number of things that we have to tackle in order to have a low environmental footprint. It's an holistic view. It's something that you have to consider as a whole, and not like different silos where you can optimize one thing without taking into account all the other. You need to optimize everything at the same time. The problem is that you have a barrier. What is the point? The point is that when you have a technology that has been proven without taking into consideration dimension, without taking into consideration weight, energy, scalability, you are just in front of a wall. Why? Because it doesn't mean that these technologies that have been proven in other environments are viable on a ship. Because on a ship you have to comply with safety, with cost, with the sea environment, and with physics. So the point is that anytime that, for example, if we talk about fuel cell are a technology that are going to be proven for stationary application. But if you think about bringing a fuel cell on board a ship, you have to comply with safety, with the fact that that fuel cell has to work in the middle of the sea with 6,000 people on board. It's pretty much different between compared to have a stationary application where you are on land without all this kind of people around. I will skip this. Few words about cooperation and about cooperation under the different frameworks of the European the framework program of the European Commission. These are some examples of projects that we carried out with any kind of possible partner. And just one last point, complexity versus allocated R&D funds. We talked about complexity before, and I hope to have convinced you that the shipbuilding is much more complex than other means of transport. But if we talk about funding, maritime is the Cinderella of all the framework programs. You can see that aeronautics, that is complex, but not as complex as shipbuilding, bring at home a lot of more funding than maritime. Conclusion. Shipbuilding is rocket science. It's not as simple as one can think. We are the world champion in high-tech shipbuilding, and this is thanks to our investment and to our competencies. R&D is important, but much more important is R&D funding and the support that the institution can give us. Thank you very much.
Thank you very much for this excellent presentation. You produced a very good illustration. The two presentations went quite well together. So we turn to a video presentation, but I'll open the floor for just one question. So I think the topic was really good. So, sir.
Yes, this is for the last presentation. I think it was a fantastic presentation. You talked about that we all have to work together in a way. You talk as if there is no intellectual property right problem that we shall aim for.
Good afternoon, everybody. My name is Peter Hook. I'm a marine biologist at the Integrale Institute in Bremerhaven.
This is the answer.
Can you just stop the presentation?
Sorry that I'm not participating in our conference today. Was multi-use.
Okay, sorry. You were saying.
Did you get my question?
Huh?
Did you get my question?
About the intellectual property.
And yes, but open innovation and no intellectual property right problem.
Well, in general, intellectual property is the main issue when we talk about open innovation. But if you consider that technologies of any kind can be applied to different kind of businesses, the model that we use usually is that when we work with the university, for example, and when we fund R&D that is specific for our business, we leave free the university to exploit the IPR on other sectors than shipbuilding. So the point is true. If we invest, we want to keep and we want to build a competitive advantage. And this advantage is based on IPR. But if we talk about basic technology development, we can imagine that universities and research centers can exploit the results in other sectors, and they are free to do it. I don't know if I got the question well.
I think you answered the question. What I hear what you are stating is that basically you are open to innovate with everyone, here you don't see any IPR problems, but if you invest heavily in a corporation where you want to get some specific advantage for yourself, then you close. Then you take out the IPR rights.
Not easily. I mean, our business is a niche compared to all shipbuilding. So if we work together on the development of a certain technology, we can arrange that I keep exclusivity for cruise ships, naval ships, and mega yachts and ferry, and you are free to exploit that technology with all the other segments. And that could be one point. Or if the technology is more general, you can exploit the technology in other business sectors, in other businesses.
Thank you for that question, and thank you for the answer. It's an interesting model here. So we will have another presentation after the break on the shipping sector, so after the shipbuilding sector. Now we're going to turn to a video presentation from a colleague of ours who could not join us today, but who was very nice to actually put this together for us. Well, we're going to look at another sector, mainly aquaculture. So we will hear from Professor Bella Buck, who's the head of the working group on marine aquaculture and maritime technologies at the Alfred Wegener Institute. So renowned professor is going to share with us some of his views on new approaches for sustainable offshore food production. So with this, let's listen to Professor Buck, and then we'll have a coffee break.
Good afternoon, everybody. My name is Peter Hook. I'm a marine biologist at the Alfred Wegener Institute in Bremerhaven, northern Germany. I'm mainly working in the field of marine aquaculture. Sorry that I cannot participate in your conference today, but I'm very, very happy that the organizers give me the chance to present my expertise and my research field here as this video. So as you all know, there's a need for marine resources, and it increases globally, especially the demand for food from the sea as well. So in this presentation, I would like to explain some examples from the German economic exclusive zone and how we can multi-use existing or planned infrastructure for the production of aquatic food and feed for aquaculture. So in that slide on the left, you can see this is the German Bight, or the German Bight within the North Sea and the EEZ. So the EEZ is roughly 30,000 square kilometers, and on the right we have the very small EEZ of the Baltic Sea. However, in this presentation I will focus on the German Bight. So I will give you a short introduction into what is currently happening in the German Bight. On that slide you can see all these cables and sediment extraction in the coastal zone, some mariculture and some pipelines and already existing platforms, mostly in the coastal sea. On that image you see all these military features, and especially here on that side, these are international large waterways, the most frequently used waterways in the world. On that image, all these red spots display the current offshore wind farms in the German Bight. And finally here you see all these nature conservation areas, especially those following the EU regulations, so Natura 2000 habitats, for example. And when you include all these different uses in one slide, then you can see that there is not too much space left. So to reduce the impact on these remaining areas, which are currently free of any usage, the only possibility, I would say, to maximize the benefit of a certain area is multi-use. However, multi-use is often misunderstood. There are quite a few different definitions, but when you put that multi-use in Google, then the first thing which pops up is that multi-use tool, for example, this Leatherman. But there are so many other definitions or terms which more or less is the same than like this multi-use. So to understand what I'm talking about is, when I speak about multi-use, I mean that we share a certain area. So as space is limited, we multi-use space. On that slide, you see a table with various potential multi-uses. So here are the renewables, for example, here are the marine resources, here are monitoring and research, traffic and others. And this side here combine all potential multi-uses with those installations which are currently at sea. And on that side, you see all the potential multi-uses for those installations which are still in the planning procedure. Red displays no possible combination, green displays yes, you can combine, and yellow, which is currently not solved. At RV, we decided not to go in all these potential different combinations. So we reduce it to some potential combinations while taking into account that wind farming is always one user, as these large offshore wind farms cover a very large space. So for example, one potential multi-use which we investigate at RV is the ecosystem protection. So since we have this large space in wind farms where currently no fishing is allowed, we create marine protected areas which we investigate. And due to the fact that we have this large amount of foundations, we are also setting up artificial reefs. I know that some people believe that this is good, some others believe that this is bad, because of various reasons. I don't want to go in detail with that. Another possibility was ecotourism, which is currently existing in Germany, that there are vessels for tourists which transfer the tourists into these large wind farms. Another potential is, of course, aquaculture. I'll come to that later. But at the same time, we also create with these artificial reefs and in the area between the wind turbines, seaweed and mussel fields for bioremediation and bioextraction. And finally, we also use the fouling which is on the wind turbine and we use fish feed on that fouling. So for you to get more insight about aquaculture, these are some examples of fish cultivation, normally in these large cages. And I would like to draw your attention to that image here. So the largest fish cage currently in use has a surface which is a little bit smaller than this soccer field of Werder Bremen, which is a football club in North Germany. Other aquaculture operations is, for example, this one here. So when you cultivate oysters or mussels, you put them on these surfaces, or they are attaching to this rough connector devices, and then you hang these devices into the sea until these mussels, for example, reach a market size. Very similar is the growing of seaweed. The only difference is that the seaweed cannot be submerged. You need to have it at the surface because the seaweed needs light. So nowadays there are other potential operations in offshore environments, as for example these fish cages. So these fish cages are different in the way as the system design has to be more robust, because it is set up in a high energy environment. You have high waves, strong currents, then you need to submerge the entire device, and finally you want to reduce the permanent stress on these devices. So as the area offshore is so rough, any attachment of aquaculture operations, it is a long line, it is a cage, to an existing infrastructure would be beneficial, as these installations are very robust, and aquaculture operations need to be a more robust mooring device to withstand these conditions. So any kind of combination would be beneficial for both uses. So the challenge for aquaculture is that you design a new kind of technology where you have more robust material, and how do you attach this to the wind farm foundation, while at the same time you need a mooring device. Then you need to have new service, operation and maintenance of harvest vessels. So it is very important that you cannot, to accept that you cannot use the infrastructure which you already use in the coastal sea, because this infrastructure is adapted to where it is currently positioned. If you bring this infrastructure into the offshore environment, it has to be adapted to these conditions offshore. And as this is far away from the coast, it would be nice to have also robotics, so that you can move the operations into a submerged mode or to a floating mode, and that you have a row of smart systems which are operating and surveilling this device. So, as there is no offshore aquaculture in wind farms currently existing, we start with all the baby steps. So the first thing in this multi-use scenario, aquaculture in a wind farm, you start with the candidates. What are the candidates I can culture? Of course, we can only use native organisms. So in the North Sea, due to the diversification process, we only have a few candidates or organisms which can be cultured, and especially here the mussel and the oysters and the seaweed and some candidates of fish. So as soon as we have defined the candidates, we need to know what technology we need to culture these candidates and how this technology can be connected to the foundation of the wind turbine. Further, where are these turbines? Are they in the German Bight at the very end, or are they very close to the coastal sea? And further, of course, it's very important that we understand that we need to have an economic potential, as most biologists have good ideas, but these ideas sometimes do not, are far away of being having economic potential. We always include economists who calculate our business. And finally, as we are covering the sea with these new uses, there are various stakeholders, and normally the stakeholders always have an opinion and everybody wants to say something. So that's why I have these rising hands here. Everybody knows something, so it is good for the project if you include all these participants in an early stage. So, however, aquaculture in multi-use is not new. This image from the Gulf of Mexico shows an oil platform on the left image. This oil platform was declared to be decommissioned, but then finally it was multi-used to attach large submergible fish cages to it. But in the German Bight, there's in the year 2000, when we started with this kind of research, there was no example for the multi-use. So the first thing the operators wanted to know, how do you want to connect any kind of aquaculture to my wind turbine or to the foundation? So we installed a large long line device, which is this device here, and this horizontal line is called the backbone, and from the backbone you have all these mussel connectors. So we connected this between two offshore constructions, foundations, and had these load cells here and there in between, and we calculated the loads. First thing was that then, with the tripod construction of the wind turbine, we calculated the static models, and then we included also into this model the different thicknesses, the material thicknesses in this foundation, which helps us to understand where we could have a potential connection point or a welding point, while also taking the vibration of the foundation due to the rotation and also due to the currents and waves into account. And then we took from our underwater load cell the data, which is not only the forces from the long line device, also the waves and the currents. And by using all these data, we then calculated the deformation of a long line and the resulting forces on the foundation. And the outcome of that was that 200-meter long line device with fully grown muscle collector, so worst case, and a 90-degree angle with the waves and currents would create roughly 100 tons of load on the foundation. So there should be an additional mooring to reduce that load on the one side to the foundation. Another example is here in this tree pipe construction. The company asked us to include a fish cage, a submersible fish cage in between. So here you can see our partner institute Franzius in the University of Hanover. They have this current flume, and to this current flume we included this tripile construction with different kinds of shapes of fish cage. Could be a cylinder or a ball-like shape, and we included also all these load cells, and then with different currents and waves we try to investigate the forces. That was done by using PIF, so particle image velocimetry, so which helps us to also investigate if the current was going from laminar into a turbulent version, and how that could eventually affect this foundation. So we also included different kinds of cascade effects, so if the vibration of the turbine and the rotating of the blades and the stress from the fish cage on the turbine and vice versa would have these cascade effects and would be even worse for the entire construction. You can also see different kinds of potential connections in here, how we could eventually connect the cage or the handle of the cage to the height of the foundation. Here you can see also the different kinds of shapes of these cages and how this cage would also be in a shelf-like mode to include flatfish, because they need more surface and not the entire volume of the cage. We also included a cage which could potentially be in between different foundation to reduce the stress on the single foundation, but at the same time enlarge the fish cage.